and good day, geometry, and welcome to geometry. As I kind of said earlier, geometry is a different branch of mathematics than algebra. There are folks who have done really well in algebra that struggled in geometry, and there are folks that struggled in algebra that do really well in geometry. Okay, if you've ever studied a foreign language before, or vocab terms in social studies, memorizing countries, science definitions, or whatever, geometry is kind of similar to that. In that you'll notice on this page, there's really nothing but, well, there's other stuff, but mostly definitions and key points. Okay, get used to that. Geometry, I'm going to teach you some wrist exercises because there's going to be a lot of note taking because there's a lot of terms that we need to cover. Okay, and we're going to start with defining geometry. Okay? Geometry is, at its core, the study of relationships within figures. Okay? The study of relationships within figures. By the time this year is through, you will all be relationship experts. Dr. Phil has got a math degree, actually. He's got a math degree, all about relationships. Okay? And what's that? Mr. Egghead? I don't know. Okay, come on back. And the whole whole point of today is kind of learn the basic players. Okay? So that when I use these words and we're using these in talking about figures or other definitions, you know what I'm referring to. Right? So a point is simply a location in space. A point has no dimension. It can't be measured. There's nothing to it. It's simply something to mark a location. Okay? And when you see a point, it's going to be a dot, and it'll be labeled with a capital letter. All right? A line is a collection of how many points do you need to make a line? This kind of goes back to graphing and slope intercept form. How many points did we have to put on the corner plane to make our line? Do you know? 2. A collection of 2 or more points. Okay? Between any 2 points, you can make a line. And that line is made up of an infinite number of points that are on it. Okay? So for example, you've got point A, you've got point B, you've got something connecting them. What do I always say you should put on your graphs when you did slope intercept form? And some of you did and some of you didn't. But to make this a line, now we're in geometry, we actually have to care about the labels. James? Arrows on each end. And what this shows us is that this line goes on forever in both directions, which is important because if it didn't go on forever in both directions, it wouldn't be a line. It'd be something else. And we'll get to that in a little bit. Okay? Segment or ray, you've heard those terms before too, probably. There are 3 ways that you can identify, three ways you can identify and label a line. The first way is with your points, A, B, and then the line notation above them. Okay? Who knows a second way? We can label that line as being line AB or, Blake? BA. You can reverse these, put a line symbol over it, and that is a second way. Okay? Sometimes you'll see a lowercase letter above the line. And it's important to know the distinction between uppercase and lowercase. Uppercase refers to the point. Lowercase refers to the line. So we could also call this line N. Okay? So it's important that when you're labeling points, you label them with uppercase letters because lowercase letters can refer to something else. It would be kind of foolish to label this line A when we already have a point A on it, but it could happen. So make sure you're taking care of that. Right? A plane is a collection of 3 or more points not in a line. Okay? A collection of 3 or more points not in a line would be a plane. We've got 4, 5, 6 scraps of paper on the floor in front of Drew and Schlafer's desk, right? They're not organized in a line, so they would create a plane, right? Yes, Mackie.
What's that word that's underlined?
Not.
Oh.
Not in a line. Sorry. So you've got point A. Here's point B. Because any 2 points make a line, to make a plane, I have to have a third point that is not in line with my first 2. Okay? And now we have a plane. Your tabletop surface is like a plane. The wall is like a plane. Okay? It's just a flat surface containing 3 points that are not in a line. Yes?
Why'd you make it a box?
Because a plane is just a flat surface. I could have made, if we got 3 points here, our plane could look like that. I mean, it doesn't really matter the shape. It's just something showing that these 3 points are all contained within that space. It'd be like if you drop 3 pieces of paper on your tabletop, right? Your tabletop is the plane that they're contained in. Same kind of thing here. Okay. You can call this plane ABC or plane BCA or plane BAC or plane CBA, any combination of those 3 points. Again, you can use a lowercase letter in the corner of the plane, and you can call this plane R. Okay? Questions so far? Okay. I mentioned here that a plane would be a collection of 3 or more points that are not in a line. Then we come to the definition of collinear. What do you think the word collinear means? Collinear.
Not in a line?
Actually, the opposite. I mean, points that are in a line. Okay. Non-collinear would be not in a line. So I could have used the word non-collinear there, but because we hadn't talked about collinear yet, I did not. But collinear would be points. Say on the same line. Okay. Collinear, points on the same line. Coplanar would be points within the same plane. Okay. Collinear, points on the same line. Coplanar, points within the same plane. I'm going to clear and scroll up, so if anyone needs any notes, get them jotted down quickly. Are we good? Anybody? Okay, all right. Now we get to some of the other non-line stuff, okay? What is the difference between a line and a segment? What is a segment? Gino?
A segment doesn't go on forever.
Doesn't go on forever, okay? So it contains at least 2 points. It has a beginning and an end, whereas a line does not. That line goes on forever in both directions. A segment has a beginning and an end. So that means is that a segment is measurable. Okay? You can take out a ruler and measure a segment because it has a beginning and an end, whereas a line cannot be measured. Okay? You can't tell me how long the number line is because it goes on forever in both directions. if I take a piece of that and say like from 2 to 6, you can tell me how long that is. It's got a measurement of 4 because it has a beginning and it has an end, right? So a segment, again, we'll just use points A and B here. Okay. Notice it doesn't matter if you put your A or your B above or below the point, just around the general area. This would be segment AB. Notice the difference in the notation up above it, right? No arrows there. Or you could call it segment BA. Okay. How about array? What's the deal with array, Joey?
So array is the beginning, but it doesn't have an end.
Right. Okay. Again, it contains at least 2 points. It has a beginning, but no end. So does that mean you can measure array? No, you cannot. Okay. What's the closest real-life application to array that you can think of? Mackie?
The equator.
The equator wouldn't be array because it connects back to itself again, you know, and it's a big circle. I mean, if anything, you could measure the equator, so if you laid it all flat, it would be a segment. So that, not quite, John? Probably lights, and a laser pointer more specifically, right? Lasers, you know, they can shoot through the sky and their light goes on pretty far. Where that light source is, that would be like the beginning, and then in theory, if it goes on forever, the sun would be a good ray too. That's why it's called a sun ray, right? It's got an origin point, the sun, and it goes on forever, okay? And so this notation would look like this, okay? No, it's got that dot on one end and the arrow on the other end. It starts at point A, continues through point B. So the notation for this would be that. Okay, ray AB. It does matter the order you put A and B in this case. It would not be correct to put BA like that. What is the difference here, Seppa? Right, B is not where it begins. Okay, so the point where it starts should be above your empty end of that notation, and the point it passes through, continues through, would be the arrow. Drew.
So if you started at B, would you flip the side of the arrow?
If you had array, like if you put BA first and then went like that?
Yeah.
Yes, that would be okay. Okay, it'd be better to put it like this because it also shows the direction the arrow is pointing, but that would not be wrong. That'd be fine too. Okay. An intersection is a point, and I know we're out of time, a point where two or more segments, rays, or lines meet or cross. I'd say intersect, but that's just using the same word in the definition. Okay? And we're going to stop there. Isn't geometry fun? That's how you math.